Hi everybody, I am Prasad. Today's my topic is single source shortest path problem. Single source from one place, shortest path. We need to find shortest path problem. This is the topic from greedy method, which is there in the 4th unit DA subject. Design and analysis of algorithm. Designing constructing algorithm and doing some analysis on algorithm. In that 4th unit is greedy method. Greedy method is one of the technique or method to design algorithms. In that 5th last topic is single source shortest path problem. This is 4th unit. For their super seniors, this was 3rd unit actually. Now recently for this semester and last semester, this was 4th unit. 4th unit, first chapter, greedy methods. Last topic is single source shortest path problem. If you want any study material, little bit zoom it. If you want any study material, if you have any doubts, WhatsApp me or call me. This is my mobile number 9849181923. No YouTuber will give mobile numbers. I am giving you my mobile numbers. This is exam time, so prepare very well and get good marks. So coming to the topic, here graph can be represented as highway structures. Graph can be represented as highway structure. Graph means G is equal to V comma E. Zoom it little bit. G equal to V comma E. G stands for graph. V means vertices. E means edges. For example, in this topic will be useful in Google mapping. In our mobile phones, we will put Google mapping. We will go somewhere else. This is a theory for that, and a graph with a problem. And we need to write algorithms, then we need to type Java programs, then the software will be created. We can go anywhere with our mobile phone having internet. So for example, I will show you. See, this is a Google map. Zoom it a little bit. Be able to see this. So this is a Google map where this application will be implemented. And my kind request is use earphones. So for better voice clarity and not to disturb other people, and use a rough notes pen and pause the video and note the points. And one more thing, watch the video horizontally. So if you watch vertically, you will see little screen. If you want any description, you need to see vertically only. If you want to see the full screen, you need to watch it horizontally like this. Then zoom a little bit so that you will see the screen clearly. Zoom a little bit, right? So then you can see the screen clearly. You can zoom, right? So now coming to the topic, single source shortest path problem. Here graph can be represented with highway structures. Generally, if you go for Los Angeles, San Francisco, Denver, Chicago, New York, any other cities will be there, states. From one state to other state, we need to find out the shortest path. Here vertices means nodes. These nodes. Here in this diagram, 6 nodes. Zoom it a little bit here. Vertices represent cities. Vertices represent cities or some states or districts or countries. From one country to other country, from one state to other state. In India, Andhra Pradesh to Tamil Nadu, Tamil Nadu to Telangana, Telangana to Goa, like that. 25 states or 29 states we can travel with the shortest path. In Google mapping, this application will be implemented after this algorithm, problem, then writing the programs. Here edges, that shoulders will represent these sides, represent highway path. Here edges, sometimes it will call it as price, cost, how much cost will be from one state to other state, and distance or length, pathway, sometimes time. Here vertices means cities or states. Overall this edge or price or time, we will call it as generally weights. Weights of the edge. For example, here 800 is the weight. It may be kilometers, sometimes this may be dollars for traveling charges. Sometimes this may be hours. That much hours we need to travel. So these are the units. So coming to one example here. These edges represent the section of the highway. One example here, zoom it little bit. 1, 2, 3, 4, 5, 6. These are vertices or nodes. Imagine cities in real life, states, one state to other state. This is a directed graph because directions have given. So this arrow mark like arrow, we have direction. So this is called directed graph. A diagram is directed graph. From one state to two city or two state, 50 kilometers. Imagine. This is this direction. From 1 to 3, this is 45. Like that we have all the directions. So here we need to find out single source. From one place to all other place, shortest path we need to find out. Here in this scenario, in this example, we are finding from 1 city or one vertex or one node to all other nodes, other cities, we are finding the shortest path. Single source, that's why it is called single source. From one city to other cities, shortest minimum distance we are finding out. So 1 to 1, from that city to that city, the distance is obviously 0. From that city to that city, that will be 0. From 1 to 2, from 1 to 2 we can travel like this. This is 50 kilometers. We need to find out any other distance is there which is less than the shortest. Shortest path is there. So for that we can travel from 1 to 4, 1 to 4, that is 10. See, zoom a little bit. 1 to 4, this direction. We need not go to same direction again. We will go there itself. We need to, our destination is 1 to 2. 1 city to 2 city. We are finding one more path, one more way, which may be shortest. So 1 to 4 we can travel, that is 10. 4 to 5. 4 to 5, that is 15. Again 5 to 2, that is 20. So this is 45. So 45 kilometers is less than 50 kilometers. So we are choosing this one. So this one, 45 is the shortest path. We are having one more distance is there, direct distance, that is 50 kilometers, but that is long distance. So we need not to choose, we should not choose that one. We need to choose shortest path. That we need to put in the Google search engine. Right, 1 to 3. Now we need to find out 1 to 3. That is the direct direction, 1 to 3, 45. We are having other distances also, that is bigger, long distance. So we need to take 1 to 3, 45 direct way. That is the shortest way. Then we need to find out 1 to 4. 1 to 4, this 10. This is the shortest. Then 1 to 5. We need to travel 1 to 4, 4 to 5. That is 25. Here. That is the shortest. Then 1 to 6. 1 to 6, there is no way. 1 to 4, 4 to 5. Direction is this side. There is no path, there is no roadway. So it is infinite. No path, no way. So it is infinite. Right? This is a direct way. This is the shortest. And one more example, one more scenario to explain the same concept. Single source from one place to all other places, shortest path. Minimum distance we need to find out the problem. Here imagine 1 Los Angeles, some city in foreign America, and 2 San Francisco, 3 Denver, and 4 Chicago, 5 Boston, and 6 New York. Like that we have 8 states, 8 cities. From one city to 2 city to 1 city traveling kilometers, imagine 300. Like that here 3 to 800. Like that all distances are given. Right, now here we need to find out, this is a direct digraph. Digraph means directed graph. A direction is there. So here the scenario is 5. We need to find out from 5 city. Imagine here. From here onwards, vast city onwards, we need to find out all cities' shortest distance. For example, 5 to 1. We have this many ways to travel. Out of this, this is the shortest way. 5 to 6, we can go from 5 to 6, that is a 250 kilometers. Again 6 to 8, 6 to 8, that is 1400 kilometers. Here 1400. From 8 to 1, that is 1700. So total 3350 kilometers. One more path is, zoom it little bit. One more path is there, 5 to 6, 6 to 4, 4 to 3, 3 to 1. That is 3450 kilometers. This is little bit bigger, not shortest path. So out of this 4, this is the shortest path. Similarly, 5 to 2. From city 5 to 2 city, this is the shortest path, 3250. So 5 to 6, 5 to 6 same 250, and 6 to 4, 6 to 4 1000 kilometers, 4 to 3, 4 to 3 1200 kilometers, then 3 to 2 our destination, second city. So like that we need to calculate, that is 3250 kilometers. 5 to 3, we have two ways to travel. Out of these two, this is the shortest. 5 to 4, for example 5 to 4 only one way, that is 1500. One more way is also there. 5 to 6 250 kilometers, and 6 to 4 1000 kilometers. This is of 250 kilometers. This is the shortest. In fact, even though 5 to 4 this is the direct way, but that is 1500. Instead of that, we need to travel 5 to 6 and 6 to, the direction is there, we can go, that is 1250 kilometers, less than this. So this we need to take. Like that, 5 city to 5 city, the distance will be 0. Then 5 to 6 250, 5 to 7 we need to find the shortest, then 5 to 8. Like that, from one city, one source, one single source, we need to find out the shortest path to all cities. So this is the two example to explain this problem, right? All the best for your exams. Write neatly.